So 4 terms. How to factor them. You get a question like this. It says factor the following polynomials. Let's pretend it doesn't even say by grouping. The first thing I would try to do is take a greatest common factor out. If you look at this, there is no greatest common factor. Right? There's no number that goes into all 4 things, and there's no letter that goes into all 4 things. So I can't do the greatest common factor. But I always try that first. Right? Then I count the number of terms. This has 1, 2, 3, 4 terms. That's when I decide it's going to be a grouping method type problem. Here's how grouping method works. You can't take a GCF out, like I said, but what you can do is you can split this question up into 2 sides. That's what we think. Cut it down the middle. I created the red side and the purple side. You just cut yours down and made the pencil side and the pencil side one. On each side, you could do a greatest common factor. So if you look at the red side, I could take a GCF out of just the red side, right? What letter could come out of the red side? X. When I take X out, I get X plus 3. And so I look at the red side, I take a GCF of X out. If I look at the purple side, I could also take a GCF out. On the purple side, I could take out a 6. I would say it's a plus 6. And I'm left with X plus 3. By doing this, by cutting it in half and taking a GCF out, you've created problems like the ones we just did. Look at your red side, look at your purple side. Do they both have something in common? Right? They both have a binomial in common that you could remove now from the entire question. So X plus 3 gets removed out. On the red side, I'm left with X. On the purple side, I'm left with plus 6. When you're doing grouping method, that's your goal, is to always get to a point where each side has a binomial I can remove. Awesome. Let's see it again. So let's look at B. I've got this question here. First thing I try is GCF. I can't. If you look, I can't take a number out of all 4 numbers. I can't take a letter out of all 4 terms either. So I count the number of terms. I go 1, 2, 3, 4. 4 terms, I'm doing grouping method. To do grouping method, I cut my thing in half right after the second term. Right there. And what I'm doing is I'm creating 2 sides. In my case, I call it the red side and the purple side. On each individual side, I could do a GCF. So if I look at the red side, I could GCF out a 2x. If I GCF a 2x out of the red side, 8 divided by 2 is 4. X squared divided by x is x. What happens when I take the negative 2x and divide it by 2x? You get negative 1. So make sure the symbol stays as a minus, because there was a minus in between them. But things don't just cancel out when you factor them out. If it's a complete thing you're factoring out, the whole term, it's a 1. And you need a placeholder there. On the purple side, we're going to do the same thing. We're going to take out, in this case, plus 3. That'll leave me with 4x minus 1. If you did grouping method properly, you should get to the same situation we just had above, where you have 2 binomials that are the exact same. In this case, they're both 4x minus 1. I can GCF that away from the entire question. And I'm left with 2x plus 3. Like that. Okay, try. Oh, sorry. I'm not going to send you off yet. I want to do C with you because there's going to be a little trick to C. All right, let's look at C together. The first two terms and the last two terms, there's nothing that can come out of all of them. So I cut this thing in half and I create two separate sides. I'm cutting it in half right after the second term. Right there. On the red side, I could GCF something out. I could GCF out a 4a. When I take out my 4a, I'm left with 2a minus 1. All right, purple side. We're going to have a bit of a problem because I don't want to GCF out a 5. Right? The reason I don't want to GCF out a 5, I'll show you, so don't copy this down. All right, if I took out a 5, I'm like, all right, I take out my plus 5. My leftover would be negative 2a plus 1. And if I look, those are opposites. If I look at my red side and I look at my purple side, they're not the same. Right? This 2a is positive, this 2a is negative. This 1 is negative, this 1 is positive. They're like the same thing, but reversed. Right? Just like we had up above, where we had that problem where it wasn't the same thing. And we said when things weren't the same and they were reversed, we would just factor out a negative, right? So what we need to do is use a little bit of intuition and understand that it has to be a positive and then a negative. So if I want my purple side to go positive and then negative, I have to factor out a negative. So instead of factoring out plus 5, I need to factor out negative 5. And when I factor out negative 5, it'll give me the proper binomial on the inside. So I look at that purple side, I factor out negative 5 to give me a positive 2a and a negative 1. Like that. Your binomials after you GCF should always be the same. If they're not the same, do something different. Right? Factor something different out. They are the same now, so the 2a minus 1 comes out front. The red side I'm left with a 4a, the purple side I'm left with a negative 5. Okay. Letter D. We're going to have the exact same issue we had in the last one. So we cut this thing in half. It creates my red side, creates my purple side. On the red side, I factor out a 3a. It leaves me with 2a minus 3. If I look at my purple side, what's something I could divide both of those terms by? Is there a number that divides into 2 and divides into 3 on the purple side? No, that's a problem for us, right? Is there a letter that could divide into each of those terms? The first one could be A, the second one, there's no A's. So if you look at that, it's kind of like, oh, I can't GCF anything. There is a number that divides into 2 and divides into 3. 1. Right? The number 1 can divide into anything. So when I can't GCF, I'm going to divide everything by 1. And that'll be my GCF that comes out. This one will be a little bit easier to make sense that I need to take something out. Because if you look, they go negative, positive on the purple side. On the red side, it goes positive, negative. It's reversed. So I'm not just going to factor out a 1, I'm going to factor out a negative 1. And that will leave me with a positive 2a and then a negative 3. So you can always GCF out a 1 if it's needed. This is the only time we really need it, right? Is on a grouping method question. Otherwise, we wouldn't really do that. You'll notice we've got two things the same. That comes out front. On the red side, I'm left with 3a. On the purple side, I'm left with minus 1. And that's your solution. Yeah, for sure. So if you look at E, we're going to do, actually try E at F on your own. See what happens. See if you can figure out when to take out a negative, when not to take out a negative. Just give it a shot. Look at E and F, there we go. Just frozen there for a second. A little different because there's no numbers involved in E. But we're still going to need to use our trick of factoring out a negative. I just want to move that down a little bit. You look at this, break it up into two sides. Purple side, red side. Oh, I've reversed it on you. That's okay, we'll survive. The biggest thing that I could take out of that purple side would be a P. And I'd be left with QR. Q plus R. On the red side, if I took out an S, it would leave me with negative Q minus R. We want positive Q plus R, right? Complete opposite. So we factor out a negative S. And it'll leave me with a positive Q, positive R. Then you have two binomials that are the same. The Q plus R goes out front. And the P minus S is left over. Awesome. F. We'll try F. I'll put it back in the proper order. So I look at it, I cut it in half. There's 4 terms. I don't like 4 terms. So I break it up into 2 separate sides. On the red side, there's no number that could go into that. At least I don't think. And there's no letter that could go into either of those sides. Right? Nothing go into X and go into Y. So what I would factor out is a 1. And I'm left with 5x squared plus 18y squared. On the purple side. If I look to see what I can take out of the purple side, I can take out a 3 from each of those, right? 15 and 6 both divided by 3. And I can take out an x from both of those sides. When I take that out, we're going to run into a big problem here. I'm going to take out a negative because that would make sense to me. But we're going to get stuck. So that would leave me with 5y squared and then minus 2. And we're stuck. The reason we're stuck is those binomials aren't the same, and they're not even close to being the same. They're very, very different. The reason that this has happened to us is all the other questions have been set up in a certain way. And this one wasn't set up in that certain way. The way that it was set up is called descending powers. Okay, so this is a term you're going to see. Descending. I think this is how you spell descending. Descending means decreasing. Powers means exponent. Decreasing exponents. To do grouping method, you have to be in descending powers, like descending order. Meaning that your highest exponent, which is x squared, should be followed by your next highest x exponent. If you look at 18y squared, there's no x's there. That would be x to the power of 0. If you look at this one, this has an x to the power of 1. This should have been the next term in line. It wasn't in descending order, which it needs to be in descending order to work. So when you get a question like this and you try doing it, right? You do your splitting it up, you do a GCF like we just did, and you end up with two binomials that aren't even close. Those things don't even look near the same. What you need to do is restart the question and reorder the question. Right? It rarely happens. You maybe will get one or two. It's just to really test you and like kind of push you. But when this happens, that's how you adjust. Okay? It's important to know how to adjust. So let's try it. Let's look and see what it looks like to reorder things. The erasing is just pain, as you can witness. Go. Alright, reordering this thing. You can reorder addition and subtraction. Actually, let's just use blue order. By just moving things around, right? 2 plus 3 is the same thing as 3 plus 2. So the same thing with variables. Just reorder them and you're fine. You're going to pick the highest exponent first. It doesn't matter whether you do y's first or x's first. I typically go alphabetical. So I would do what has the highest exponent with an x on it. I would say 5x squared is the highest exponent for x. Then I'm going to ask myself, what's the next highest exponent that I see on an x? And there's actually two, right? Like I could do this guy right here, which is x to the power of 1, or this guy right here, which is x to the power of 1. I'm going to do negative 6x. But it could be the other way around, right? That could be the one you need. But we're just going to try putting this one first. Negative 6x. Then I do the next highest exponent I see on an x. The next highest exponent I see on an x is negative 15xy squared. And the last one is the one with no x's, which would be this guy, plus 18y squared. That is now written in descending power. Okay? The highest exponent on x, then the next highest on x, then the next highest on x, and so on and so forth. Fantastic. Now that it's properly set up, we can do our grouping method. We look at this side. I can take out an x. It leaves me with 5x minus 6. If I look at the next guy, I have negative 15xy squared plus 18y squared. I know I want my negative to be the second thing, so I'm going to take out a negative 3y squared. When I take out a negative 3y squared, it'll leave me with positive 5x. And then negative 6. Now, when you've done your grouping method, you've split it in half, and you've GCF, you get two things which are the exact same. 5x minus 6. Okay? That's as hard as grouping method could realistically get for you. You had to reorder it, you had to factor out a negative, and then you had to do your next step, which is take out your greatest common factor. But that's a hard question. Okay? You'll see maybe like one at that level. And then you're left with x minus 3y squared. Any questions about that one? That's tricky.